The effective performance of automation systems is significantly dependent on the proficient integration of discrete I/O signals, including inputs derived from sensors. These signals are crucial in facilitating these systems to execute their intended functions with the most accurate outcomes possible. 24-volt DC is a widely accepted and safer option for most industrial automation sensors, as many DC sensors are designed to function at this voltage level. When dealing with 24-volt DC sensors, it is common to encounter the terms PNP and NPN, which can be challenging to understand as they are frequently used in the industry. In this video, you will learn what an NPN sensor is. You will understand the behavior of an NPN sensor concerning sensing or not sensing an object in its proximity. You will be demonstrated with wiring an NPN sensor to a PLC and get advice on avoiding common errors. And lastly, you will be taught how to use a multimeter to test or identify an NPN sensor. Let's dive in without any further delay. The first step is to check if the circuit is designed to accommodate NPN sensors. To achieve this, consider this DC circuit that consists of a power supply, a 2-wire proximity sensor, and a load which could be an alarm device. The NPN is shorthand for negative, positive, negative. The middle letter P in NPN stands for positive polarity and serves as a reminder of a direct connection of the load to the positive side of the power supply. It's an easy yet practical way to recall the side of the power supply to which the load is directly connected. Target detection of the 2-wire proximity sensor triggers conventional current flow from the supply's positive terminal towards the load, enters the brown wire, passes through the sensor, and exits through the blue wire to the negative end of the supply. As the 2-wire proximity sensor draws current from the load to sink it to the negative side of the power supply, it is known as a sinking sensor in this specific circuit. If you swap the 2-wire proximity sensor with a 3-wire proximity sensor, the wiring configuration will become more complicated. However, later in this video, you will learn how to analyze it section by section to simplify it. The internal circuitry of a 3-wire NPN sensor typically contains 2 main components: the sensing element circuit and an NPN transistor. The sensing element circuit is designed to detect the presence of objects located within the proximity of the sensor. Once an object comes into the sensing range of the sensor, the sensing element circuit transmits a signal to switch on the NPN transistor immediately. What about the NPN transistor? Well, you can think of it somewhat as a switch that controls the current flow in the sensor. With the transistor turned on, the current can flow through the sensor. In contrast, when the transistor is turned off, the current flow within the sensor is disrupted. Unlike passive sensors, active solid-state 3-wire NPN sensors typically require an operating power to function. 2 of the 3 wires attached to the sensor are responsible for delivering the energy needed for the sensor to function. So the power wire, identified by its brown color, is connected to the positive side of the power supply, while the blue wire is attached to the power supply's negative terminal. The signal output wire of the sensor, which connects to the input terminal of the load, is identified by its black color. This wire is the 3rd wire of the sensor. The placement of an NPN transistor between the negative voltage wire and the sensor signal output wire in an NPN sensor enables negative switching to occur. To jog your memory, the middle letter P in NPN stands for positive, indicating that the load's common terminal must be connected to the positive side of the power supply to establish an electrical circuit. If you consider taking an alarm device as the load in this circuit, you can delve more clearly into the operational principles of a 3-wire NPN sensor. When the 3-wire NPN sensor doesn't sense any metal object, the active line goes low, causing the NPN transistor to switch off and function somewhat as an open switch. So it leaves the NPN output circuit open, resulting in no current flowing through it and the alarm device remaining off. The sensor's detection of a metal object causes the active line to go high, then turns on the NPN transistor to act like a closed switch and activate the alarm device. Consequently, the circuit allows the current to flow from the positive terminal of the power supply through the load toward the NPN transistor and ultimately reach the power supply's negative terminal. Since the NPN sensor can be considered as receiving input power from the load for syncing it to the ground, it is commonly referred to as a syncing sensor. When a PLC discrete input module is used instead of the alarm device, the procedure of wiring the NPN sensor to the PLC will be similar to the NPN sensor connection to the alarm device. However, there are two considerations to bear in mind. First, PLC discrete input modules are offered in two configurations, syncing and sourcing. For this video, you are provided with a brief overview of the sourcing type. With this configuration, the common terminal of the PLC is connected to the power supply's positive terminal, and the input channel of the PLC module is internally linked to the positive voltage. The second consideration is to ensure that the sensor type is compatible with the PLC input module, thus guaranteeing proper functionality. It is crucial to select a field sensor type that is complementary or opposite to the type of PLC discrete input module used to have reliable performance. Now let's revisit the circuit. Since the NPN or syncing sensor has been incorporated into this circuit, it is imperative to use a sourcing PLC discrete input module to match it. Finalizing the circuit requires attaching the sensor output represented by the black wire to the input of the PLC module and then linking the common terminal of the PLC module to the power supply's positive terminal. When the NPN sensor identifies a metal object, it activates the sensing element circuit to emit a signal that turns on the NPN transistor, enabling it to function somewhat as a closed switch. Therefore, the current flows from the power supply's positive terminal and enters the common terminal of the PLC. From there, it passes through the input channel of the PLC and proceeds toward the NPN transistor before returning to the power supply's negative end. Lastly, you will discover how to test the NPN sensor to ensure it operates correctly. To do so, make sure you have a multimeter on hand and consider 24 volts DC as the primary supply for the sensor. If the NPN sensor doesn't detect a metal object, then you can expect that the sensor's output voltage will be high, which indicates that it is supplying a voltage nearly equivalent to the power supply to the input of the PLC module. Let's get the multimeter into play. Attach the multimeter's red lead to the NPN sensor's black wire and connect the black lead of the multimeter to the ground. As you predicted, the multimeter shows a voltage almost the same as the power supply. Now you expect when a metal object enters the detection range of the sensor's output voltage will be pulled down to almost 0 volts. And as you figured, you can see this voltage on the multimeter too. Also, the voltage reading will be influenced by the transistor, causing it to be consistently 1 to 2 volts higher. Don't forget to share your opinion about this video in the comment section. Also, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out-of-the-oven videos. This way, you keep motivating us to produce more informative videos.